Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: VPC Peering and Connectivity. Virtual Private Cloud Peering and Connectivity in Amazon Web Services is a pivotal topic for any aspiring AWS certified cloud practitioner. VPC peering allows you to connect one VPC with another via a direct network route using private IP addresses. Instances in either VPC can communicate with each other as if they are within the same network. This concept is integral to AWS networking, enabling seamless and secure communication between VPCs, which may be in different accounts or regions. VPC peering facilitates the creation of a more extensive network architecture within AWS by allowing multiple VPCs to communicate with each other. This communication is essential for various use cases, such as cross-region replication, shared services, and hybrid cloud architectures. The need for efficient network connectivity in the cloud cannot be overstated. According to a Gartner report, by 2025, over 85% of enterprises will have adopted a cloud-first principle, making network connectivity and integration a critical consideration. The technical underpinnings of VPC peering hinge on its ability to leverage the AWS global network infrastructure. When two VPCs are peered, AWS uses the existing physical infrastructure to route traffic between them. This process ensures low latency and high throughput. Furthermore, VPC peering is designed to be highly available and durable, leveraging the inherent redundancy within AWS's global network. One of the primary benefits of VPC peering is the enhancement of security. Communication between instances in peered VPCs occurs over private IP addresses, which means that traffic does not traverse the public internet. This setup reduces the attack surface and helps maintain compliance with various regulatory requirements. Additionally, VPC peering supports network isolation, enabling enterprises to segment their network for better security management. This is particularly crucial for organizations that must comply with stringent security standards, such as those in the financial services or healthcare sectors. However, implementing VPC peering requires meticulous planning. AWS imposes certain limitations and best practices to ensure optimal performance and security. For example, peering connections are non-transitive. If VPC A is peered with VPC B and VPC B is peered with VPC C, VPC A cannot communicate with VPC C through VPC B. This restriction necessitates careful network design to avoid creating a complex and unmanageable network topology. Moreover, there are limits on the number of active and pending VPC peering connections per VPC. AWS initially sets these limits, but they can be increased upon request. It's also worth noting that VPC peering connections do not support IPv6 traffic by default. To enable IPv6 communication, each VPC must have an IPv6 CIDR block, and the route tables must be updated accordingly. Financial aspect of VPC peering is another critical consideration. While there is no hourly charge for creating and maintaining a VPC peering connection, data transfer fees apply for traffic sent across peered VPCs. These costs can add up, particularly for data-intensive applications. It is therefore essential to monitor and optimize data transfer to manage costs effectively. An illustrative example of VPC peering can be seen in a multi-region architecture. Suppose an organization has a VPC in the US East region and another in the EU region. By establishing a VPC peering connection between these two VPCs, the organization can ensure that applications in different regions can communicate securely and efficiently. This setup is beneficial for disaster recovery and high availability, as it allows for the replication of data across regions. According to AWS, using VPC peering for cross-region connectivity can result in a 50 to 70% reduction in latency compared to traditional internet-based VPN connections. In addition to VPC peering, AWS offers other connectivity options such as AWS Transit Gateway and AWS Direct Connect. AWS Transit Gateway enables the attachment of multiple VPCs and on-premises networks to a single gateway, simplifying network architecture and management. It supports transitive routing, which is not possible with VPC peering. This feature is particularly useful for large enterprises with complex network requirements. On the other hand, AWS Direct Connect provides a dedicated network connection from on-premises infrastructure to AWS, offering lower latency and higher bandwidth compared to internet-based connections. These options provide flexibility and scalability, allowing organizations to choose the best connectivity solution based on their specific needs. Despite its advantages, VPC peering has some limitations. It does not support transitive routing, which can complicate network design. Additionally, there are limitations on the number of active VPC peering connections, and managing a large number of peered VPCs can become cumbersome. Therefore, while VPC peering is suitable for smaller, simpler setups, organizations with more complex networking needs might benefit from exploring AWS Transit Gateway or AWS Direct Connect. Security concerns also play a crucial role in VPC peering. AWS ensures that VPC peering connections are secure by default. However, network administrators must configure security groups and network ACLs appropriately to control traffic flow between peered VPCs. Best practices include using security groups to allow only necessary traffic and regularly auditing security settings to ensure compliance with organizational policies. To maximize the benefits of VPC peering, network administrators should follow AWS best practices. These include planning the IP address ranges for VPCs carefully to avoid overlap, which can prevent successful peering. Additionally, administrators should regularly review and update route tables and security groups to ensure optimal routing and security. In conclusion, VPC peering is a powerful feature in AWS that facilitates secure and efficient communication between VPCs. It offers numerous benefits, including enhanced security, high availability, and cost savings. However, implementing VPC peering requires careful planning and consideration of limitations such as non-transitive routing and data transfer costs. By understanding these factors and following best practices, organizations can leverage VPC peering to build robust and scalable network architectures within. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.